Our team here at KSC has been working on this STS-125 mission for basically about 2.5 years.
And we've had the hardware here now for probably, what, 6 to 9 months?
The flight hardware first started arriving in July 2008. We did have some ground support equipment and other associated hardware arrive a few months earlier.
Well, let's look at a tape now, some of the activities of the payload activity going on in the clean room in the payload hazardous servicing facility, and you can tell us some of what this flight hardware is that we'll be seeing. All right, Debbie, what can you tell us is going on here?
So the Hubble hardware integration began in the payload hazardous servicing facility in a contamination-controlled environment. Operations in the high bay were restricted to minimal personnel working around the scientific instruments, the flight elements, and the carriers. All the flight hardware was inspected to a visibly clean, highly sensitive standard, which required real-time monitoring of particulate and hydrocarbons, blacklight inspections, tape lifts, witness mirrors and plates to maintain and ensure the cleanliness. Right now we're doing a blacklight inspection of the flight hardware. Here we have the fine guidance sensor. The fine guidance sensor consists of a large structure housing a collection of mirrors, lenses, servos, prisms, beam splitters, and photomultiplier tubes. It locks into guide stars, helping the telescope point. They can also be used as instruments to measure the position of stars in relationship to other stars. The astronauts will replace one worn-out fine guidance sensor with a refurbished model that was removed during a previous servicing mission. Here we start inspections again. This is the Cosmic Origin Spectrograph, or COS. It is designed to study large-scale structure of the universe and how galaxies, stars, and planets formed and evolved. It will help determine how elements needed for life, such as carbon and iron, first formed, and how their abundance have increased over the lifetime of the universe. A spectrograph is an instrument that breaks light into its component colors, revealing information about the object emitting the light. COS sees exclusively in ultraviolet light and will improve Hubble's ultraviolet sensitivity at least 10 times and up to 70 times when observing extremely faint objects. The COS is placed in a protective carrier for flight. Now we're looking at the Wide Field Camera 3. The Wide Field Camera 3 will be powered behind studies of dark energy and dark matter, the formation of individual stars, and the discovery of extremely remote galaxies previously beyond Hubble's vision. Now we're seeing the IMAX camera as it's being installed onto the ORUC carrier, which is the Orbital Replacement Unit carrier. This is the FSS, the Flight Support System. It will be used to latch on to the Hubble Space Telescope for on-orbit servicing activities. This is a good wide-angle view of the entire high bay of the PHSF as we continue servicing operations. Now we're looking at the Scientific Instrument Command and Data Handling Unit. In late September 2008, only 2 weeks before the planned servicing mission 4 to Hubble, a malfunction occurred in one of the systems that commands the science instruments and directs the flow of data to the Earth. The failure of one of Hubble's control units after 18.5 years of successful operation was corrected by switching to a backup system that was built into the telescope to restore scientific functionality. However, because this is such a critical system, NASA was unwilling to leave the telescope without another backup in case of future problems. And here we're finishing the installation of that backup Scientific Instrument Command and Data Handling Unit. This is the payload canister. It makes a trip into our rotation facility where it will be rotated vertical to support our activities out at the pad. As the canister travels to the pad, the contamination control operational restrictions move with the payload. Operations that are restricted include controlled burns, asphalt and concrete work, even insecticide, fungicide, and herbicide spraying, welding, exterior spray painting, and many other overall operational activities. As we make the trip out to the pad on the transporter on April 18th, we can see that the transporter moves fairly slowly in the vertical configuration. Two of Hubble's instruments, the Advanced Camera for Survey and the Space Telescope Imaging Spectrograph, are also in need of repair. The Advanced Camera for Surveys is responsible for some of Hubble's most spectacular images. This Space Telescope Imaging Spectrograph is a spectrograph that sees ultraviolet, visible, and near-infrared light and is known for its ability to hunt black holes. While COS works best with small sources of light, such as stars or quasars, STIS can map out larger objects like galaxies. It actually suffered a power failure in 2004 and was put into hibernation to preserve the possibility of its repair. Here we're seeing inside the orbiter payload bay as we get ready for closeouts and payload bay door closure. This servicing mission will be the final trip to the Hubble Space Telescope. Over the course of 5 spacewalks, astronauts will install 2 new instruments, repair 2 inactive ones, and perform the component replacements that will keep the telescope functioning at least into 2014. And here we see the actual payload bay doors for their final closure and ready for flight.